Hi, today we will present report for Bej30403 Electronic Circuit Analysis and Design. The project title is 6 Order Bandpass Active Filter. This presentation is made by Group 2, Session 2. So, hi, my name is Heng, TE200126, and Mr. Lai, TE200062, and also Mr. Lam, TE200091.
Hi, my name is Lamji Teng, and my metric number is DE2091. Now let me start with introduction. In this assignment, we are required to design and simulate a 6-band pass active filter by using operational amplifier. And there are some specifications for our group, and which is the mid gain we have to need to adjust it to 95, and the low cutoff frequency is 300, and the high cutoff frequency is.
I will present the theory and conclusion. So for the second frequency is 774.5967 Hz, and the bandwidth is 1700 Hz, and the quality factor is 0.4556. So this is the two-order low-pass filter. So at X0, V negative equal to V naught RA over RA plus RF, and the amplifier gain is equal to 1 plus RF over RA. So at Y0 is equal to VY minus V negative over R2, and at Z0 is equal to SC2 V negative. So we assume R1 until R6 equal to R, and assume the capacitor 1 until capacitor 6 is equal to C. Thus, the over gain will be AV equal to V odd over V initial equal to AV naught over RCS squared plus 3 minus AV naught RCS plus 1. Next, the cutoff frequency for low-pass filter is 2000 Hz. So it's a high cutoff frequency. So we use the formula FH equal to 1 over 2 pi RC. We assume the value for R is 10 kilo ohms. So we use this formula to calculate the capacitance is equal to 7.9577 nanofarad. Therefore, we can say that R1 until R6 resistor is 10 kilo ohms, and also the capacitor C1 until C6 is equal to 7.9577 nanofarad. This is a table, so we see the n equal to 6, so we can get the gain for the section is 0.518 and also 1.414 and also 1.932. So here we calculate the ratio. So for the first AV01 we get 2.482. So we get RF1 equal to 1.482 RA1. So for second, 3 minus AV02 is equal to 1.414. So AV02 is equal to 1.5x6. So RF2 is equal to 0.5x6 RA2. So we assume RA1 is equal to 10K. So RF1 is equal to 14.82 kilo ohms, and RA2 is equal to 10 kilo ohms. So RF2 is equal to 5.x6 kilo ohms. For the third, 3 minus AV04 and AV03 is equal to 1.932. So RF3 over RA2 is equal to 0.06x. So RF3 is equal to 0.06 RA3. So assume RF3 is equal to 10 kilo ohms. So RF3 is 0.06 kilo ohms. So RA1 until RA3 is equal to 10 kilo ohms. RF1 equal to 14.82 kilo ohms, and RF2 equal to 5.x6 kilo ohms, and also RF3 is equal to 0.06 kilo ohms. So this is the second order high pass filter. So at S0 we not multiply with RA divided by RA plus RF. So at Y0 equal to VY minus V initial equal to 1 SC capacitor 2. So at Z0 the formula is Vy minus V negative divided by 1 over S capacitor 2 and V minus divided by R2. So we let R7 until R12 equal to R, and C7 capacitor 7 until C12 equal to C. So the overall gain will be AV equal to V naught divided by V initial equal to AV naught divided by 1 over SRC squared plus 3 minus AV naught divided by SRC plus 1. So the cutoff frequency for high pass filter is 300 Hz and the is a low cut-off frequency. So we use the formula FL equal to 1/2 pi RC. So we assume our value resistor R equal to 10 kilo ohms. So we can calculate the capacitance equal to 53.052 nanofarad. Therefore, we can set R7 until R12 equal to R equal to 10 kilo ohms, and also capacitance 7 until capacitor 12 is equal to 53.052 nanofarad. So Av04 is equal to 0.518. So Av04 is equal to 2.482. So we can find the ratio is Rf4 is equal to 1.482 Ra4. We assume Rf4 is 10 kilo ohms, and also we calculate the Rf4 is equal to 14.82 kilo ohms. So for Av05 is equal to 1.5x6. So the ratio is Rf5 is equal to 0.5x6 Ra5. So Ra5 is 10 kilo ohms. So we can calculate Rf5 is equal to 5.x6 kilo ohms. So for the last, Av06 is equal to 1.068. So Rf6 divided by Ra6 equal to 0.068. The ratio is Rf6 equal to 0.068 Ra6. So we assume Rf6 is equal to 10 kilo ohms. So we calculate Rf6 equal to 0.68 kilo ohms. So conclusion, Rf4, Rf5, Rf6 equal to 10 kilo ohms. Rf4 is equal to 14.82 kilo ohms. Rf5 is equal to 5.86 kilo ohms, and also Rf6 is equal to 0.068 kilo ohms. So by using the formula again for our circuit, so N0 is equal to all the Av0 multiply, so we get the N0 is equal to 17.67. So to achieve the mid-gain, which is 95, so we add a non-inverting amplifier. So we need to find the gain for the non-inverting amplifier. So AX equal to 5.3x. So we proceed to calculate the RAX and RFX. So we get the ratio for RFX is equal to 4.38 RAX. So we assume RAX equal to 10 kilo ohms. So we calculate the RAX equal to 43.8 kilo ohms.
Okay, let me explain the complete circuit diagram and also the component list. And we need, first of all, we need to design three of the second order low pass active filter, and then we connect it to second order high pass filter, and then finally we connect it to a non-inverting amplifier. And then we see the component list. They are using IC 741 operational amplifier. And then for the resistor, we for R1 until R12, we use 10 kilo ohm. And then the RA1 to RAX, we also use 10 kilo ohm. And for the RF1 and RF4, we is 40.82 kilo ohm. And the RF2 and RF5 is 5.86 kilo ohm. And the RF3 and RF6 is 0.68 kilo ohm, and the RFX is 43.8 kilo ohm. And for capacitor C1 until C6 is the 7.9577, and the C7 to C12 is 53.052.
Hello, my name is BOON. My matrix number is DE200062. I am going to present about the analysis and discussion part. So the value of our group for the mid gain is 94 ampere, while the value of the low cutoff is 300 Hz, and the value of the high cutoff is 2K Hz. From the specification of the active filter given, we can use them to calculate the value of resistor and capacitor. After getting the value of the resistor and capacitor, we can use them to design and stimulate our sixth-order bandpass filter using OM. Though the result from the stimulation of the active filter and the comparison between the manual calculation and stimulation are shown in the table below. So therefore, based on our result, the stimulation value is always slightly different with the calculation value due to the internal and external factor. So in conclusion, bandpass filter has a wide range of application in the present world. These filters are widely used in wireless transmitter and receiver. Besides, these bandpass filters are also used in instrument and application of medical and seismology. Throughout this assignment, we are able to design and simulate a 6-order bandpass filter using OF. In order to design a 6-order bandpass filter, we need 3 high-pass filters and 3 low-pass filters and a non-inverting amplifier. Based on the result from the simulation, it can be concluded that all simulation values are slightly different with the manual calculation values. Last but not least, even though the simulation values do not have the same value as the manual calculation values, but it still maintains the filter behavior or characteristic. So that's all for our presentation. Thank you.